Now I'm going to leave the thing mounted with one screw and use that other hole as the guide to make sure that I get the hole drilled in the exact position that I want. And I rotated this cable connector 90 degrees out of the way, and that way I can make sure that it is exactly where I want it. I decided to use my lithium-ion powered portable drill, cordless drill, because it's small enough that I can get in there, and it spins at high RPM, which my old Milwaukee 90 degree, which I always started to drill the holes with, it goes a little too slow. That's much better. It's got a lot more torque, and it's good for like it's a good hole hog for drilling holes through 2x4s when you're running electrical wires and stuff like that, plumbing. But it isn't really good for this job. So I start drilling the hole through the metal bracket here on the circuit breaker just to guide it. And once I know that it's started, I then move the bracket out of the way and finish drilling it. That way I don't damage the small thin metal flange here on the breaker. So now tap that hole. All right, that's all mounted. Now I can reattach this wire and then make a new wire to go from here over to the ammeter. Well, I don't have any more of that heavy gauge red copper wire, so we'll use the neutral out of that cable that I got that red wire from. So white is going to be the color. And so now I got to put a connector on one end to go from the breaker, and a connector on the other end to go up to one of the connections on the ammeter, which I also need to check that ammeter and make sure it's not shorted, because a shorted ammeter is not good. Time to test the ammeter. Now I'm not going to test it to see if it actually functions. I'll do that when I get this all hooked up and running. What I want to mainly see is I want to see if there's a short. Now you get two posts on the ammeter, and then the body of the ammeter is metal and it's grounded to the frame here. So what we want to see is we want to see 0 ohms or what looks like a short from one post to the other. Because an ammeter, which measures current, when it's in series in the circuit, it should offer virtually no opposition to the current flow. However, if either one of those posts has a short to ground, it would indicate that there's an internal short in the ammeter, and the ammeter will have to be replaced. So I've got my multimeter set to the ohm scale, and I've got it set to the continuity feature, which gives me a tone when I have continuity. So now I basically just got to get up there and put one on each post of the ammeter. You can see there's 2 posts there. It's starting to get dark. Alright, good news. I'm getting continuity from one post to the other, and I'm not getting continuity from either post to ground. So the ammeter may very well be good. That's the first test. So I know that I can hook up the ammeter in the circuit, and it should pass current, and it shouldn't cause a short. However, it doesn't tell me whether or not the needle's actually going to move to indicate whether or not there's current flowing through it. So that would be the second test, which I'll do that once I get everything hooked up and running. Okay, now the other side of the ammeter is going to have a couple of connections. We're going to have the wire that sends the 12 volts down to the solenoid on the starter go there, and that's also going to be the way that the power is going to run through from the alternator through the ammeter back to the battery to charge the battery. And that's also going to be how the 12 volts gets to the solenoid, and then the other wire coming from the solenoid is going to go to the key switch here. So got to figure out which one of these 2 wires, because they're the same color, is the one that's the actual 12 volt. Okay, quick check with the voltmeter tells me that this is the one that's hot. In other words, this is the one that's going down to the solenoid and back to the battery. So this one's going to go up to the other side of the ammeter, opposite the terminal that the alternator battery terminal is hooked up to. Alright, so now we can do a test over here. Now remember, the ammeter should offer virtually no resistance to the circuit, and since we now have it in series, we've got the battery current or voltage should be able to feed back to here. So I should get 12 volts from here to ground. and I do, which is, whoops, there we go, 12 volts. So right now I'm reading the battery, and that tells me a couple of good things. It tells me my wiring job is good going back, and it also tells me that the alternator is grounded via this bracket, because remember, I didn't run any ground wires, so that's good news. Alright, now let's get rid of some of these connectors off of here. We know that white and red are being used for the alternator circuit. One's for the reference voltage and or voltage sensing, and the other one, well, that's to help the regulator work properly and maintain proper voltage as different loads like lights are turned on, and also to keep a good level so that the battery will be charging. The white one, I believe, is going to be the wire that's going to go to the what we call the idiot light circuit, or the charge light. But the main purpose of that is when you first turn the ignition key on before the motor is running, 12 volts from the battery will run through the light and actually send voltage to the alternator to set up a magnetic field to excite the alternator. Once the engine starts and the alternator starts spinning, it will start producing its own voltage, and it will be able to sustain that magnetic field on its own. It will no longer need that voltage to keep it excited, which will cause the voltage on the alternator side of that circuit to rise, balance out with what's on the battery side of the circuit, and because you'll have 12 volts or equal voltage on both sides of the light will go out. So what's supposed to happen is the idiot light, when you turn the ignition on, your idiot light comes on, or your alt light comes on, and then after you start the engine, the light should go out. And if it doesn't, then you start your diagnosis to figure out what circuit's at fault, or if it's lit dimly. There's all different things that can happen that can cause different symptoms, but we'll get to that later if necessary. So I cut off the connector on the black wire, and I'm not concerned about the green wire right now because they both are for the auxiliary fuel pump. So now I got to cut these spade connectors off of the end of this cable. Now I'm going to strip those two wires. Now this cable is actually way too long right now. This is not what I'm going to finish up with for a finished length, but I just want to jumper in a few things right now and see if I can't test this circuit. I should have realized from the darkness how late it was. I've got father-in-law's coming over for dinner, so I got to get ready to wash up and be prepared for that. So I'm going to have to start cleaning up my tools. So I'm going to quit for tonight.